Hello, everybody. I'm a professor in the field of transportation at the Central South University. Today is my best pleasure to share with you the interesting topic of my field, intelligent transport systems. We abbreviate it as ITS. I will introduce some emerging ITS technologies and research progress based on China practice. I am the founding director of Smart Transport Key Laboratory of Hunan Province, Central South University. I earned my PhD degree at the National University of Singapore and worked as a postdoc research associate at the University of Central Florida. I'm currently serving as the editor-in-chief of the journal Accident Analysis and Prevention and associate editor or editorial board member for several premier international journals in the field of transportation safety. For the topic of ITS, the lecture will be divided into two units. The first is about the ITS systems in urban areas, especially for how the advanced technologies have been applied in big cities of China. In the Unit 2, I will deliver some progresses in the emerging field of intelligent and connected vehicle development and their potential safety impact in the future. And some research questions will also be presented to stimulate popular thoughts and innovative technological development. In comparison with most developed countries in North America, Europe, and Australia, China was actually a bit late in fostering the ITS industries and developing wide applications. But given the rapid social and economic development in the past 40 years, China has experienced an amazing period of urban development and subsequently rapid motorization in transportation field. By the end of 2020, the total length of motorway and expressway are 5 minutes and 160,000 kilometers, both of which are ranked number 1 among the countries. The extensive expansion of road transportation systems also lead to the rapid increase of motor vehicle ownership, which is around 400 million in total by 2020. The total number of licensed drivers are over 450 million. Seen from the slide, starting from 1990s, we have been initializing a number of national actions to develop the latest technologies in intelligent transportation systems, so as to deal with the urban transportation problems, including traffic congestion and the traffic crash. The ITS applications have been speed up with the important events of Beijing Olympic Games 2008, Shanghai Expo 2009, and the Guangzhou Asian Games 2010. Since 2010, the development has been more comprehensive and extended to multiple objectives, not only for congestion and safety, but also for relevant environmental problems like traffic noise, traffic pollution, and energy saving. Moreover, this has not been limited to the traffic management field, but also on operational field of both passenger and freight transportation fields. As stated in the national strategic documents, transportation informatization has been stimulated by excellent policy and environment at both national and local government level. And from 2011 to 2017, China's smart transportation market maintained a growth rate of more than 10%. In 2017, the market size of smart transportation reached 635 billion yuan, with an average annual compound growth rate of around 11%. Driven by the sustained growth of market demand, it's predicted that China's smart transportation will maintain an annual compound growth of a rate of about 13% in the next 5 years. And the industry market size is expected to exceed 1.5 trillion yuan by 2024. By the end of 2018, the market size of smart transportation projects with over 10 million was about 20 billion of 1,167 projects. The market size increased by about 13% compared with 2017. And the growth was mainly due to parking and transportation informatization projects. And in the following, I would like to present several major technologies in the urban ITS field. The first is the very best, but most important thing about road intersection signalization. Everybody has waiting for rail signals, and traffic engineers try to optimize the signal timings to maximize the intersection capacity. In this regard, intersection signalization are generally designed to provide optimal vehicle traffic flow and to distribute the signal time to conflicting flows from different traffic approaches. Note that the signalization is not only limited to motor vehicles, but sometimes even more importantly, for pedestrians and the non-motorized vehicle passing the intersection. And timing planes may be of two general types: fixed time or pre-timed, and actuated. Pre-timed intersections operate in predetermined and predictable fashion. Actuated signals change the length and or order of the phases in response to variations in vehicle or pedestrian traffic. Coordinated signals and systems provide automated control of signal timing to two or more signalized intersections. Instead of looking at an intersection in isolation, coordinated systems look at an entire arterial or network of intersections and make signal timing adjustments that benefit the operation of the entire system. And the system changes a result of traffic volume and travel times. Most often, a central controller provides the primary control and communicates individual controllers located at each intersections. And a very important research topic is to coordinate the traffic signal timings for adjunct intersections based on predicted travel time distributions. The second is intelligent traffic guidance system. The most applied is the roadside VMS guidance control system. The variable message sign and the lane control sign system is referred to VMS guidance control system, which is mainly composed of full matrix VMS and lane control sign, LCS, and speed limit sign, VSL, local controller, lane detector, and the communication collection system. The control software is composed of a collection of control software and so on. The detection system collects the traffic flow status of each lane and feedback to the control center in real time. With other detection devices, such as weather monitoring, the control center computer uses the control algorithm to instruct the VMS to display the guidance information and guide effectively vehicles to run in an orderly manner to avoid the traffic congestion. Once there is an abnormal condition on the road, the control center will make timely adjustments and reflections based on the feedback information of the detection systems and deal with the planned procedures. Of course, the personnel of the control center have the actual situation if combined with the CCTV monitoring situation. The system can be controlled by human intervention. When necessary, if serious road accident occurs after the road management personnel arrive at the scene, they can also use the scene controller near the scene to perform the highest priority intervention control on the VMS around the scene. Highways and expressways, especially expressways or ring expressways around the city or between cities, are characterized by closed roads, many lanes, multiple junctions, large traffic volume, and obvious traffic tidal phenomena. The introduction of VMS guidance and control system has played an obvious role in traffic diversion, which has been widely used in cities in China. Currently, onboard unit is generally equipped with advanced vehicles. In this case, the guidance information could be sent along with the onboard navigation system for more personalized guidance service, containing not only dynamic road traffic information but also real-time safety information. In guidance system, cameras are widely applied to detect traffic conditions. If you drive in China cities, you may find that various types of cameras are everywhere. They are beside the roads, overhead the drive lanes, and on the poles around the intersections. Most of them are used for traffic surveillance purposes. The cameras are connected with each other by high-speed fiber optic network and gathered to the traffic management centers. As such, traffic management personnel are able to view and control the full traffic conditions indoor. Therefore, huge traffic surveillance screens are generally installed in the center. Yes, the cameras are not only for overviewing, but more importantly, to automatically detect and enforce the traffic violations and abnormal driving behaviors, such as reverse driving, illegal lane occupation, low giveaway, illegal parking, no barcode, red light running, overspeeding, hit and run, etc. Those cameras are intelligently connected with each other for different scope and purpose, forming objective environment combination systems, unit entity combination system, and site area combination system. Some of those systems are not merely for traffic surveillance purposes, but also for social security purposes. By integrating the image information with those from cameras installed in residence or commercial areas, the functions could include macroscopic view, key information display, multiple level linkage, real-time visualization, full process control, etc. Urban traffic management and control is an extraordinary, challenging task. Supported by the detection systems, decision-making at levels of planning, design, construction, management, and maintenance could be data-driven and hence more scientific. The general procedure is from data integration, model development to decision simulation and evaluation. In last decade, almost all the megacities have constructed ground transportation management center. With big data application, traffic model systems have also been developed for traffic status evaluation, traffic congestion analysis, and travel time estimation and reliability analysis. Deep analysis for evolution mechanism of traffic flow and traffic network state evaluation has also been explored, including traffic flow characteristics analysis based on complex network theory, dynamic analysis of traffic time series at different temporal scales, simulation and evaluation for urban road network is extremely important for the purpose of smart transportation operation and management. This is done by constructing of GIST platform, regional traffic simulation model, and regional traffic operation analysis platform. This is example of city-level meso simulation system, which is developed by CSU team for Changsha urban road network. In the system, all the road segments and the intersections have been digitalized, and the traffic flow on the network is calculatable. Therefore, all kinds of evaluation for policy or control strategy could be implemented. Promoting public transit is a major measure to resolve the urban traffic problem in China. Development of intelligent public transit system is a long and steady policy in China. Those includes electrification, high efficiency and green transportation energy power system, intelligence collected and assimilation of transportation system integration, experience sharing and integration of transportation users' consumption demand, quantitative, accurate, and scientific decision-making in transportation management. A full set of systems for intelligent public transit have been applied, including bus monitoring, dispatching, command system, enterprise, integrated information management service system, public transport, industry management information system, decision analysis system for public transport industry, public transportation information service system. Public transit system is a multi-model consisting of bus transit, subway system, shared car, taxi, etc. An essential technology is multi-modal transit coordinated operation system based on intelligent control. It requires multi-source data fusion and analysis, multimodal transit coordinated operation and dynamic optimization and information integration. And the next is intelligent parking management systems. Given the serious problem of parking space supply limitation in urban area, the parking-related systems have formed a huge and rapidly developing car park industry, consisting of different types of software and hardware systems. The provision of personalized information for drivers to park their cars has been an important direction for technological advance with deep application of big data and AI. The roadside parking is a typical application. The workflow is from vehicles entering berths, sensing vehicles, and uploading data to platform, order generation, and send to the mobile phone, vehicle leaving berths, sensing vehicles, and uploading data to platform. The order is completed and sent to the mobile phone and self-service payment. All the procedures are done by automatic mode. The functions of the system include real-time monitoring, recognition of vehicle plate number, checking the fare in real time, mobile payment automatically, displaying the space availability. This is the technological workflow for the smart parking services. The apps and the equipped hardware and software systems provide a full trip non-personal parking services. The parking systems are also connected with traffic guidance system, and therefore the parking guidance information could be displayed on specific roadside VMS. This function is also available in cell phone apps. The picture demonstrates a 4-level parking guidance mode, from route choice at arterial level to parking space selection at street level to specific parking vacancy information and to individualized vehicle terminal level. In order to further increase occupation rate of parking spaces, some innovative modes are invented. This is an example of shareable parking operation system. In this case, the parking spaces at residential and commercial areas could be shared so as to balance the usage of parking resources. Specific mobile apps have been developed to link different sorts of participants with real-time information, business to customer and customer to business and to customer, modes are adopted for different scenarios. A key component for this demand is the integrated parking information platform. The platform should integrate the parking information from different partners and should also be collected with the traffic management center so as to integrate the interacting and optimal strategies for both static and moving traffic. In this case, car park data and the traffic flow data are merged to support the decision-making regarding road network planning, parking planning, and the relevant policy making. So this is the first part for introducing the urban intelligent transport systems.